According to the U.S. Department of Commerce, Illinois' multi-billion-dollar livestock industry is in decline. Recent figures show the state ranks 11th nationally in the number of cattle finished and 4th in swine production. That is a drop from 7th in fed cattle numbers and 2nd in swine production just a few short years ago. A major reason for this decline is new environmental regulations in our state and public protests regarding livestock odor and waste pollution. Producers are faced with requirements that land-applied livestock waste may be considered a violation of environmental pollution regulations. These issues are having a chilling effect on smaller producers in the Midwest who might otherwise consider expanding livestock production. Municipalities are also facing major changes in the way they handle their waste streams. Landscape waste, typically natural organic materials such as grasses, leaves, and wood, can no longer be burned or dumped into municipal landfills. As a result of these regulations and public protests, researchers are trying to get the two parties to work together. They believe there is a way to use these wastes as a soil amendment without adversely affecting the environment. An attractive solution for both farmers and municipalities is through composting. Composting is an age-old practice of waste management whereby the organic components of the waste streams are biologically decomposed under controlled conditions to a stabilized state in which they can be safely handled, stored, or applied to land as a soil amendment. Composting can occur in the presence of oxygen, referred to as aerobic composting, or in the absence of oxygen, referred to as anaerobic composting. Most modern compost systems are aerobic for important reasons. They are generally free from objectionable odor, pathogens and problem weed seeds are made inactive, and the process is inexpensive, requiring little technological input. Of the three primary methods of aerobic composting, the windrow method is generally considered the most cost-effective. The secret to successful aerobic composting is the speed at which raw materials break down and the quality of the compost ultimately produced. The most important factors in achieving both requirements are moisture content, carbon to nitrogen ratio of the raw materials, and the temperature achieved during the composting process. In practice, the moisture content of composting material should not be allowed to drop below 45 to 50%. Nor should it be allowed to rise above 65 to 70%. One method of maintaining moisture is to add liquid swine manure to a windrow. Liquid swine manure also adds nitrogen to the mixture, a necessary nutrient required by the bacteria to accomplish the composting process. Another important factor in composting is the carbon to nitrogen ratio. Initial mixtures of raw material prior to composting should have carbon to nitrogen ratios ranging between 25 to 1 and 30 to 1. A check of carbon to nitrogen ratios will help determine what combination of raw materials is suitable for composting. To speed up composting, it is important to maintain aerobic conditions and proper temperatures within each windrow. Windrows ready to compost should be turned daily for the first 3 to 5 days, 2 to 3 days per week for the next 3 to 4 weeks, and once weekly thereafter until the 8th week or until the internal temperature of the windrow drops below 100 degrees Fahrenheit. The materials needed for successful composting fall into two basic categories: carbon materials and nitrogen materials. Most high nitrogen materials, such as livestock manure, have similar characteristics. They tend to be wet, decompose quickly, are not very rigid, which means they lack structure, and have a high bulk density. Because they tend to decompose quickly, most high nitrogen materials have an odorous quality about them. Carbon materials like leaves or corn stalks have properties that complement the high nitrogen materials. They are drier, low in nitrogen, have a low bulk density, which means they are a fluffy, airy material that is still somewhat stiff and rigid. They decompose slowly and have a relatively low odor potential. Therefore, given the complementary characteristics of these two groups and the need to dispose of these materials in an environmentally safe manner, it becomes evident that combining them in a composting system is an attractive solution. Selecting appropriate raw materials and the correct combinations of materials is critical to successful composting. For example, a roughly 50-50 mixture of livestock manure and landscape waste will produce a mixture containing 50% moisture and a 25-to-1 carbon to nitrogen ratio, which is ideal for the composting process. Other carbon sources such as wood chips, sawdust, dead leaves, straw, or corn stalks can be windrowed, and livestock manure can be added periodically over several weeks to achieve acceptable carbon to nitrogen ratios. Because carbon materials decompose slowly, they can be stockpiled until needed. Corn stalks and straw harvested with a stacker or large square baler are more conducive to making windrows than forages harvested as large round bales. It is important to keep unwanted items out of the waste to be composted. So while leaves are a generally clean carbon source, other yard wastes often contain unwanted trash and must be inspected prior to composting. Foreign objects like plastic, metal, or concrete do not compost, will contaminate the final product, and can damage equipment. Therefore, it is important to educate the general public and instill ownership in a composting program. Bringing together the factors that create good conditions for compost are what make it challenging. Individually, these elements do not come close to the appropriate moisture content or carbon to nitrogen ratio. That is why the mixing part, or the recipe development, is so important. The goal is to combine materials to create a balanced carbon to nitrogen ratio, moderate moisture content, moderate pH, and low bulk density. The result is cured compost, which also represents a 50 to 60% reduction in the volume of the original raw materials used. If proper temperatures are reached during composting and if proper blending occurs, weed seeds can be successfully eliminated. During a typical heat cycle where internal temperatures in the compost reach 150 degrees Fahrenheit and the moisture content is about 50%, weed seeds are destroyed in approximately 2 days. In windrows where the peak temperature is less, the time needed to kill weed seeds increases. If the composting process does not thoroughly incorporate all materials into the heat cycle, incomplete weed seed and pathogen inactivation may occur. A temperature of 131 degrees Fahrenheit for more than 2 weeks is enough to kill disease organisms. There are 3 types of compost: fresh, mature, and cured. Fresh compost has been through the thermophilic stage, has reached temperatures above 120 degrees Fahrenheit, and has achieved sanitization. Although fresh compost has undergone partial decomposition, it is not stabilized and it continues to break down. Mature compost is generally suitable as an organic soil conditioner. However, because it is only partially stabilized, it may temporarily arrest plant growth if it comes in direct contact with plant roots. Cured compost is a highly stabilized product, which has resulted from exposure to a prolonged period of humification and mineralization beyond the stage of maturity. Cured compost makes an excellent organic soil conditioner. Compost is classified as Class A or as Class B. Class A compost includes cured compost and is often referred to as designer compost. It is suitable for lawn and garden application and as an amendment for potting soil. Class B compost includes fresh and mature compost, and its use is best suited as an agronomic soil amendment. Researchers at Illinois State University are working to determine the effects of using compost as a soil amendment for crop production. Ken Smiklis, an agronomist with Illinois State, is studying the effects of compost application rates on the soil and the plant. Both mature compost and raw compost have been applied at different rates to 2 fields at the university farm. He has discovered that many soil properties, such as pH, soil nutrient level, and the cation exchange capacity, have not been altered by compost application. Dr. Smiklis reports that when compost is applied to the soil at proper rates, both corn and soybean plants yield about the same as when conventional chemical fertilizer treatments are used by growers in central Illinois. The Illinois EPA limits agronomic application rates to 20 tons of compost per acre, although exemptions for higher application rates can be obtained. Findings also indicate that by increasing the rates of compost on fields where corn is grown, yields are higher. This finding was expected, since higher rates of compost supplied more nitrogen to the corn plant and therefore stimulated grain yields. However, for soybean, there was little correlation between the rates of compost and yields. Since soybean acquires nitrogen via nitrogen fixation from the air, it is not as dependent on nitrogen fertilizer as is corn. These and other important studies using compost as a soil amendment are continuing at Illinois State University. Researchers will continue to monitor long-term effects of compost application on corn and soybean production. The Illinois EPA, Bureau of Land, and Bureau of Water regulate composting, and in some instances, permits may be required. For livestock operations larger than 1,000 head, a National Pollutant Discharge Elimination System permit may be required. If the compost is sold, a siting permit is required. If livestock manure is combined with landscape waste and exceeds greater than 10% of the total volume, an EPA organic waste composting permit is required. Selecting an appropriate compost site is very important. Generally, permits are not required for farm compost sites if the site is located on the farm on which the compost is to be applied, appropriate setbacks are followed, such as 1/4 mile from the nearest non-farm residence and 1/2 mile from the nearest populated area, it's protected from a 10-year floodplain, does not discharge runoff, the site is 200 feet from the nearest potable water, and is operated by the farmer who is not a partner nor employee of a waste hauler or generator. Generally, a compost siting permit is not required if livestock manure is mixed at appropriate rates with farm-generated carbon sources, such as corn stalks or wheat straw. For more information on compost siting and other permits, contact the Illinois EPA, Bureau of Land, and Bureau of Water in Springfield. Meeting federal, state, and community environmental standards is important to everyone and cannot be overlooked. In order for composting to be successful, a partnership between the farmer, the municipality, and the public must be fostered, nurtured, and promoted. Composting is a practical, economical, and environmentally safe way for all of us to coexist in the disposal of these wastes.